Today I'm going to be talking about biodiesel, what it is, how it's made, and its environmental and economic impacts. Biodiesel is one of the major renewable fuels being used today, and it plays an important role in the transition away from petroleum-based diesel. Biodiesel is a renewable fuel made by chemically converting natural oils and fats into a diesel-compatible fuel. There are different blend levels such as B5 or B20, which are mixtures with petroleum diesel, and B100, which is purely biodiesel. The overall goal behind biodiesel is to create cleaner burning alternatives that lower transportation emissions. Most biodiesel comes from vegetable oils or waste fats. In the US, soybean oil is the main source, whereas in Europe, often uses rapeseed oil, and Asia uses palm oil and recycled cooking oil. It's produced using a process called transesterification. First, the oils are filtered, then they react with alcohol and a catalyst, converting the triglycerides into FAME, fatty acid methylate esters, which is biodiesel. The byproduct is glycerol, which gets separated and used for other industrial purposes. These oil crops rely on photosynthesis, taking carbon dioxide, water, and sunlight to create chemical energy stored in the plant's oils. When the biodiesel burns, the carbon itself inside the fuel is released through respiration like oxidation, forming carbon dioxide and water. Because the carbon originally came from the atmosphere, the overall cycle results in lower net carbon emissions compared to fossil fuels. As for the development of biodiesel, it is not experimental. It is a fairly mature technology and widely available across the nation. Many countries require biodiesel blends in their transportation sector, but in the US, vehicle fleets can even earn regulatory credits for using biodiesel. Feedstock demand has risen sharply, up from 19 billion to 32 billion units since 2021, indicating that interest and usage continues to grow. Biodiesel can reduce greenhouse gas emissions by up to 74% compared to petroleum diesel. It also reduces particulate matter and pollutants like carbon monoxide, sulfur oxides, and nitric oxides. The main drawback is cost. Feedstock dominates the expense, and production typically adds 20 to 50 cents per gallon. A 2022 estimate showed that producing 6 billion gallons could cost nearly $49 billion, which limits the expansion and affordability. In order to support biodiesel adoption, communication efforts focus on educating the public about benefits, how biodiesel works in current engines, and how it compares to petroleum fuels. Outreach also helps build trust in using waste-based feedstocks and higher blend levels like B20 or B100. B20 is 20% biodiesel, and B100 is 100% pure. For our current analysis, overall, biodiesel is a strong renewable fuel option. It's effective at reducing emissions, but the high cost of crop-based feedstock slows large-scale growth. Waste oils and fats offer a cheaper, more sustainable alternative. Strong policies are needed to prevent deforestation, support high-blend users, and help biodiesel producers stay viable. If funding were not a limitation, the best plan would be to focus on expanding waste-based biodiesel, build production facilities capable of processing multiple feedstocks, and power those facilities using renewable energy to kill two birds with one stone. We could also invest more in public education and create stronger incentives for commercial fleets to use high biodiesel blends such as B100. This is the list of cited sources used in this presentation. Thank you for listening to my presentation on biodiesel, and stay energized.